Hey all, this is Karthik and welcome back to your favorite channel on data structures and algorithms. So I am going to talk about topological sort in this video and I'll take the example of a dependency resolve tool to talk about topological sort. I'll start from the very basics and the video will cover everything that you need to know about topological sort, and it will not cover everything you need to know about a dependency resolve tool because focus will be on the algorithm, but I'll give you a very basic of what a dependency resolve tool is and what it helps in doing. So a dependency resolve tool is any tool that helps in resolving dependencies, of course. Now imagine that you're building a project and in the project there are many packages or files. Taking a very basic example, I would say that let's say I'm building a small project and that project has three files, file A, file B, file C. Now file A has some functionalities that depend upon some functions provided by file C and file B and C. So let's say that file A depends on file B and C. Now file B depends upon file C. Let's say it's using some functionality that is provided by file C. Now you will see that these files are interrelated and dependent on each other. File C does not depend on any other file, that's cool. Now, how do you start building those files or including them? Let's say file A wants file B and C's content to be already built or present before it gets built on its own. Okay, because file A will be using some function or some method that belongs to file B or C. Now, file A would want that to be already there, compiled, built, and ready for it to use. So what should be the correct order in which we should build these packages or files? So for a small project, you can manually just go ahead and build or include the files as you would like. That's up to you. But when you're working on large scale projects where there are thousands, 10,000s or lakhs of such files and packages, it's actually almost impossible to do that manually. A dependency resolve tool will first of all evaluate the correct order in which it should build those packages and then next actually do the job for you. So let's get to the actual learning now. And imagine that I have a package A that I wish to build, but package A has some dependencies. Package A depends on B, C, and D. So this means that I cannot build package A till I have the functionalities of B, C, and D available with me. And B might also depend on some other packages. So let's just for example sake say that B depends on C and it also depends on E and F. Now package E might depend on F, maybe. Let's say package C depends on F and package D depends on G and H. So let's say these are the packages and this is the package A and this is the dependency graph that I've built out of it. Okay, so G and H do not depend on any other package. F also is an independent package, but all the other packages either directly or indirectly depend on other packages. Now, how do you find out the correct order in which you should build these packages so that you don't have a dependency issue? So this means that if I'm trying to build C, I must already have the functionalities that are provided by package F. Otherwise, I will have some compilation errors or other problems. Now, if I'm talking about this smaller project, I might be able to do this manually. I'll build F first, then I'll build G and H, I'll build C, then maybe E, then I might be able to build B, D, and finally A. But how do you come up with a robust algorithm that will be able to handle 100,000 packages, hundreds and thousands of packages, or maybe lakhs, millions? How do you come up with a robust algorithm for this dependency resolve thing? Also, before we come up with an algorithm, let me talk about one of the key scenarios in which it's impossible to build a project. Imagine that C depends on F and maybe F depends on C. So this is the case of a circular dependency and you will not be able to resolve this. Because when you're trying to build C, you need F. But when you're trying to build F, you need C. So this will be a circular thing. And circular dependencies could be like this also. A depends on B, B depends on C, and finally C depends on A. This is also circular dependency. You will not be able to build in this type of scenarios. Now having talked about this, let's move ahead. How do you come up with an algorithm? Now I am trying to build A. Here's what I will think. Since A depends on B, C, and D, If I were to find the correct order for A, let me just forget about A for now. Let me try and build B first, because that has to be done before getting to A. So let's think about an easier problem, and that problem is, how do you find out a correct order to build B along with its dependencies? And if you're able to do that, then you'll think the same about C. How do you build C along with its dependencies in a correct order? Same way for D. And once you've thought about that, if you have found out the correct orders, then you can just build A, because you are done with the correct order for B, C, and D. So let's talk about this in more detail using code. Let me remove this for now. So imagine this is your package structure. Okay, you have the name of a package that was A, B, C, and D. It could be other packages, of course. This is the package code. You don't need to have it. I just wanted to make it seem a bit cool. These are the dependencies of a given package. So this would be some package A, B. A might depend on B, C, D. A list or a vector of packages are the dependencies for a given package. Now, this is how your algorithm will work. When you're trying to build A, here's what you will do. You will try to build B first instead of building A, because B is a direct dependency of A. So you will think about B now. Now, when you're trying to build B, you will think about E and F. Now, remember that initially I was trying to build A. But I saw that B was a direct dependency, so why not try and find a correct order for B first? When I came to B, I found out that, hey, C is a dependency of B. So let's just delegate. Now, instead of building B, let me try and build C along with its dependencies. So I went ahead and I thought, cool, I'll think about B later. First, let me build C along with its dependencies. Now, when I reached C, I found out, hey, C has a dependency F. Let me try and build F along with its dependencies in a correct order. So I went for F. Okay. Now, when I reached F, I found out, hey, F is not having any other dependency. So why not just build it? So cool. I found out that F along with all of its dependencies can be built in a correct order, and that is just build F. Now, once I was done with F, I marked F to be a package that is already built. I went back to C. I said, hey, C, now since you don't have any other dependency, F is already built. Why not I build C also? So I built C. I took the package C, I built C right after building F. Now I went back to B. And also, I marked C to be a package that is already built. Now coming back to B, I see that F is a dependency of B, but I find that F is already built, so I don't even care about that because F is already present. I find that E is also a dependency of B, so why not build E first? Because I want to try and delegate the tasks as far as possible till they are solved on their own. So I try to build E along with all of the dependencies that E has. I reach E. I find out that E only has one dependency, and that is F. But I also know that F is already built because of this tick mark here. So I say, cool, now let me build E. And I mark E to be built. Now I reach back to B. I see that all the dependency of B are already built. So why not build B now? So I build B and go back to A. And this order is correct for building B. F, C, E, B. This is a correct order for building B. Next, coming back to A, I find that C is a direct dependency of A. So why not build it first? But I find that C is already built because of that tick mark, of course. So I ignore it. And then I think about D. So I go to D, since D is a direct dependency of A. Now D also has dependencies G and H, and let me just fast forward it for you. I build G, I come back to D. I build H, I come back to D. I build D, I go back to A. Now since all the dependencies of A have already been built or resolved, I build A. And that's the overall idea. This is topological sort. Let me get to the code here, and this will be very clear for you after that. So we're trying to find out the correct order. Let me take vector string. We'll be giving the name of the packages in which in the order in which you should build them. Let me say resolve dependencies, and I'll pass in a package that needs to be built. Let's say package P needs to be built. In fact, should I pass in a pointer to the package? Would be better, I guess. Pointer P star, package P star. That would be better. Alright, so I'm passing a package that needs to be built. Should I pass in anything else? I guess that's enough. The function should return a correct order in which you should build the packages in order to build this package P along with its dependencies. You should resolve them and give a correct build order. How do you do that? So here is how you can do that. Let me just delegate my task for now. I'll build a function named get correct build order. I'll pass in this package, of course. And for the tick mark thing, which I said, okay, hey, I'll just mark it tick. This package is done. This package is done. How do I do that? I'll just keep in an unordered set of packages and I'll say, okay, done or not. So maybe something like this. Unordered set package star built or not. Okay. So this is a list or set of packages which are already built. Okay. I'll pass this. Initially, there is no package already built, so it is empty. This get correct order will also let me build another vector that will hold the names of the packages in the correct order. And I'll return correct order. This is the correct order in which you should build the packages. Let me also pass this to this function get correct order. Now let's build this function here. Void get correct order. I will take in a package that I need to build, and I will also take the vector correct order because you need to put in the package whenever you build it. You put that package in there that maintains the correct order. Okay. This is a vector of string %. If you have any doubts, guys, you can ask me in the comments. I am always happy to help you out there. Now this function get correct order is going to help me build a correct order in which you should build the packages. Now I am trying to build the package P. If it is already built, I should do nothing and just return. Okay, so if already built dot find, if this package P is already built is not equal to already built dot end, that means package P is already there in the built packages, then just return. You don't need to do anything, right? Otherwise, what should you do? Otherwise, you should first build all the dependencies of package P, find the correct order for them, and then finally build package P as well. Also, guys, currently I'm assuming that there is no circular dependency at all. After this, I will also take the case where there are circular dependencies. And how do you actually reject if there is a possibility of a circular dependency? Okay, so if the package is not yet built, you should go ahead and build it. So how do you do that? So for every dependency of this package, so for every dependency of package P, that is, okay, so for every dependency belonging to the dependencies of package P, build them first. You will say, okay, get correct order for this dependency first and then build P. So it's as simple as saying get correct order for this given dependency. Pass in the other extra auxiliary data structures. Now, once all the dependencies are done, the correct orders for them have been found out, you can actually go ahead and build this particular package P and put it in already built packages. Insert. So this package is now already built, or you just built it, and also put it in the correct order. Dot pushback p dot name. And guys, that's it. That's as simple as it gets. Now if you think about it, every time you find a package, you go for the dependency of that package, and then you just keep following the same thing recursively. Let me take a small example and dry run it for you. Sorry. A, B, C, and back. I'm trying to find out the correct order for A. I pass in this already built, which is empty, and correct order, which is also empty right now, to this function get correct order. This will receive a package for A. The name of the package is A, package code, and I will not show you, confidential. And then the dependencies, which are B and C. Is it already built? No, it's not already built. Cool. Go ahead. Look at the dependencies of A. B is a dependency of A. Okay. Then get correct order for the dependency B. Pass in the auxiliary data structures. You reach for B. You say, okay, get correct order for B along with these extra structures. Is B already built? No. Okay, then look at B and its dependencies. B has a dependency C. So, okay, get correct order for C first. You go for C. Is C already built? No, it is not. Okay, then look at the dependencies of C. C does not have any dependencies, so this loop does not run. Now I can build C. So I will insert C into the already built packages. So C is now already built. This is equivalent to putting a tick mark at C. Correct order dot pushback. So this means that in the vector correct order, C is now inserted, the name of the package. I return back from the call at B. And since there was only one dependency for B, that was C, this loop ran once. Now I reached here, I will build B. I will insert B in here and correct order dot pushback B. That means in this vector, I'll put in B here. And after that, I'll return back to A. A called for B. Now A will call for C. I will go for C here. I will find that it's already built. I'll return. I'll do nothing. I'll come back at A. Since B and C, both the dependencies of A are done, I will reach here. I will build the package A, insert it into the already built set, and then correct order dot pushback A, and that's the correct order CBA. So that's the code here. Now imagine if there were circular dependencies. What should you do then? So here's what you can do. Let me insert another variable, bool build fail, or let's say build possible. Is it possible to even have a build for this? And let me say initially I feel that it is possible, so I'll pass in a true. But if I find out that it's not possible, I'll mark that variable false so that I know. So if wait, I'll do one thing. Let me say I build possible. Initially, I think it might be possible because otherwise, why will the user ask me to do that? Now I'll pass in this variable build possible to my function get correct order. And if this is still true after coming back, if this build possible is still true, I will return the correct order. Otherwise, let me just return something that represents failure. I should actually throw an error, but I'll just return an empty vector for now. Okay, simplicity sake. Vector package star something empty. Okay, cool. So how do you actually find out whether it was not possible or not, or whether this is cycle or not? See, I'm passing in this boolean build possible for sure, and I should mark it false if it's not possible. See, here is when it will not be possible. Imagine that there is a package U, and let's say U is currently being built. It is under the process of being built, under construction, and I'm building some packages that U depends on. Once all these packages are done, I will mark U to be built. But imagine when I'm trying to build B, it is under construction, it is being built currently. I find the package V that depends on U. This means that I'm trying to build U, but I found a package that was a dependency of U, either directly or indirectly, which depends on U. This means that there is definitely a circular dependency, because if V wants U, either U is already built or can be built, but not currently being built. Because if it's being built, then that means you wanted V as a dependency of U. So if I keep a track of the packages that are currently being built, then I can find out whether there's a circular dependency or not. So if there is a package U that is currently being built, and you find a package that you're trying to build so that you can build U, but that package itself depends on you, then you are in trouble. You cannot actually be happy because U depends on V depends on you. There's a circular dependency. So here's how I'll keep track of these. I'll keep a track of the packages that which are being built or under construction, or being resolved is a better word. But let me just go for being built. So this is a track of the packages that I'm currently in the whole process of building. As soon as I reach package B is under construction. Being built, dot insert P. Also, as soon as I've built it, I can remove it from the being built set because it's built. I can just remove it from here. Okay. Or erase, I guess. So as soon as you start building a package, it is under construction or it is being built. And as soon as you have built that package, it's no longer under construction and you can remove it from the being built set. How do you find out our dependency? So let's say that this particular guy, this dependency variable here, is a dependency of P. And if this dependency is currently being built, if being built dot find dependency is not equal to being built dot find dot end, that means this particular guy here is currently under the construction, but P also depends on it. This is a definite case of circular dependency. I'll show you how. In this particular case, you can mark in build possible as false and maybe just return. Also maybe just for just for efficiency sake, initially just check one more thing. If either this or build is not possible or build possible, build is not possible, just return. Don't waste your time. Cool, that's it. Let me just show you an example. Imagine something like this. A depends on B, B depends on C, but C also depends on A. Now I'm trying to find out the correct order for A. I pass in all the variables. A is currently being built, so A comes under the being built section. Now A will call for B, B comes under being built, B calls for C, C wants A as a dependency, but A is under construction right now, so that is a definite case of circular dependency. So you reach this particular case and you avoid that, you return and you mark build possible as false. So hopefully guys you liked this video, you found this helpful. Actually we talked about a few things that I like to summarize here. We talked about topological sort first. We talked about how to find a cycle in a graph by that being built concept, and we also talked about somewhat what a build resolve tool does. So if you like the video, make sure that you hit the like, subscribe, share button, whatever you can do to help me out. So bye guys, hopefully you liked it.